Good morning all. Here's the power section of a Vickers servo drive 70 DBC 3-F18, and it's got a shorted regenerative braking IGBT. Now the IGBT is inside the power module that makes that motor get up and go. So here, this is our three-phase bridge. I'm going to get on bus ground and I'm going to put my meter on the brake terminal. That's a dead short right there. Now the rest of the power module is good, but since that regenerative braking IGBT is inside that power module, we can't use the rest of it. So let's take this drive apart and we'll remove that power module. Let's take the drive apart. Down here are 3 voltage regulators that we have to undo from this mounting plate back here. Drop the screw down there and I don't see it. Where'd you go? Oh, there you are. Okay, gotcha. Put the nut back on the screw so we know where it goes. The lock washer. And when you go to put this drive back together, be careful of this one right here because it has an insulating washer and some insulating material. They want to isolate that ground from the back plate. If you don't put all that insulating materials back on, then the output will be shorted to ground. This is the negative terminal, which pinout is a little bit different from the other regulators. That insulating washer from down there. That's it right there. We need to put that back on that terminal regulator right there. So I won't lose that insulating washer. Do the three-phase bridge wires. I have pictures of all the points where these wires go. I took pictures with my camera. I always try to get pictures so that I can get the drive put back together the way it should go when I take it apart. Do these wires from the IGBT. Come on. There we go. Okay. Go ahead and cut this wire tie right here. Okay, now we'll remove the 4 screws that hold the IGBT to its heat sink assembly. Come on. Come on. There you go. That's my hold up here. Bumping into that transformer. Okay, now be careful when you go to remove this, because right under here, back under here, is a heat sink thermal. Can you see that? We need to undo that screw right there. Just just need to be careful that we don't rip the wires out of the board. The wires come up through here. There's a hole in the board, and the heatsink thermal connects right there. Okay. There we go. Get that plate off of there. Set this over here. I'll screw this back in so we know where it goes. There's our three-phase bridge made by Fuji Electric, 6RI75E-080. We can set this off to the side. There's our power device right there. And its part number, made by Mitsubishi Electric, part number PM75RSK060. Now it's damaged. Now we can't get inside that thing and try to repair it. That would be impossible. So the easiest way to get this out is to reach up in here and snip the gate emitter and power wires, the power supply wires, on the gate emitter sides, and then rock this back and forth until we snap the P, N, B, UVW terminals from the power supply board, and then we'll use our solder sucker and suck the vias out of the pins that were left behind. Let's get our side cutters, and we'll go to work on it. Almost there. There. Whew. That took a while. Ready for the new one to go in. Before we do that, I'm going to replace these capacitors right here. Let it sit over the top of that IGBT. Here's the new power module we're going to install, and here's the old one we just took out. This is the P terminal. This is the B terminal. That's where you attach your regenerative braking resistor. Here's the N terminal, U, V, and W. Now, let's check the new one before we install it. I'm going to put my red lead on the N terminal. There's the P terminal. The B terminal should be open. That's good. U with the black lead, V, and W. Now I'm going to take the black lead and put it on the P terminal. Here's B. We have a diode drop, that's good. Here's the N terminal again. U with the red lead, V, and W. Let's go look at what we took out. Red lead on the N terminal. Here's P. And the B terminal shorted. U, V, W. Black lead on the P terminal. There's our diode drop again, that's good. N terminal. U, V, W. So the B terminal to N is a dead short. Good morning all. Here we are, day 2. Now what we're going to do is we're going to insert the power device, the IGBT power module, onto the power board. I've already recapped this section right here because once you put this on, you can't get to the back side of those capacitors. Now these other capacitors, if I have to, I can replace those because they're outside the area of this IGBT. Let me clean up that board right there real quick before I insert that IGBT. Some denatured alcohol. Clean up my work here where I did that recap. Okay, we'll let that evaporate. Okay, we're ready. Now this takes a little bit. What I try to do, here's the old caps. What I try to do is I try to get the gate emitter pins inserted first, and then I'll insert the power pins. This takes a little bit because these don't quite want to line up at the get-go. Everybody's wonky off to one side and whatnot. There we go. Look at that. That was easy. Huh. Nice. That went in easier than I thought it would. We take and put a little bit of heat sink grease. Just a thin coat of this heat sink grease on the back side of the IGBT. Doesn't take a whole lot, just a thin coat. This will fill the hills and valleys of the metal and allow good heat transfer to the heatsink assembly. Put a little bit more over here. There we go. Now before I solder this to the power board, I mount that power board to the heatsink assembly. That way this will be in its proper position. If you don't mount it first to the heatsink assembly, like say I soldered it right now, if it wasn't in the proper elevation between the heatsink assembly and the IGBT and the power board, I might buckle this power board or bow it inward. So we're going to mount it first. First thing we have to do is connect the heatsink thermal. What I'll do is I'll pull out as much slack as I can, because if you don't have a lot of slack, it's hard to get this thing connected back. Turn it this way. I need some light. Put my headlamp on. I had this little lamp, fits on my head, it gives me some light so I can see down in the dark. Okay, sit right there, screwdriver. I'm gonna need you in a second. Don't be squirrely. Oh, I almost had it. Give this a little bit of a bend over so it'll sit flat. Makes you wonder how they do this at the factory, because I can barely do this here. Oh, okay, that lock washer's coming off. It ain't going on. Hard enough to get the screw down there, much less the screw and the lock washer. Gotta figure out a way. Maybe this will work. Nice to have those magnetized screwdrivers. Yeah, let's set this flush. I got an extra washer. Okay, is that tight? Yeah, it's tight. Okay, let's slide this over. There we go. There's all the parts. These screws right here mount the IGBT to the heatsink assembly. Out here. Come on, left hand. Come on, right hand. Y'all work together. Okay, I'm not going to tighten them all the way down. Not yet. Okay, now we're going to mount the voltage regulators to the back plate, the mounting plate. They don't give you no room over here. Okay. Set this on there first. Okay. I'm leaving the lock washers off of these ones too because I can't insert the lock washer and the nut and have it all stay on there while I'm screwing everybody together. It's just near impossible since my left hand don't always want to cooperate with what my brain is telling it to do. I think the rule here is don't have a stroke. Don't have a brain stroke. Now this one right here, it has insulating material between the plate and the terminal of that regulator. And then here is an insulating washer made of plastic. So you don't want that negative output to short to the ground of the other two regulators. That's why the insulator is on there. This one, I have to somehow get it on there. Let's see. And then these, what makes it tough is these capacitors are in the way. Oh. Okay, did I get it on there? Yeah, okay, let's see if we get the nut on there. Okay. I make that look easy, don't I? Get there we go. Screw in the wrong place. It's supposed to go back there, and the standoff's supposed to go here. Now we can tighten everybody down. After we get everyone tightened down, we'll solder that IGBT to the power board. There we go. Okay, we'll fire up the soldering iron. And we'll be ready to solder that IGBT to the power board. Get these wires out of the way here. Got a few extra washers. But like I've always said, if you don't come out with extra parts after you get done with the job, you did something wrong. Okay, Let's fire up that soldering iron. Let's see if we can solder in the power section first, and then we'll do the gate emitter. Let's turn my light on. I kind of push these off to the side because we have to get right into these terminals right here without trying to melt anything in the area. Let's see if we can get this one first. There's one. There's two. Let's around this side. Let's see what's the best way to go in here. I don't want to burn these wires. See if I can go in like this. Oh, got to get something to hold them wires back out of the way so I can get down through here. Come here. What can I use? Maybe I can use my finger right there. Don't let go, finger. Okay, there's that side. And we'll go ahead and hook up the wires on this side. Okay, there's black. Blue. And gray. Now for the gate emitter side over there. Turn my heat down on my iron a little bit. I had the heat raised a little bit so that these large traces and terminals wouldn't soak up the heat. These are a little bit difficult because you have to go down through these capacitors. Turn this around this way so I don't melt the labels on those capacitors. close-up glasses on. Too much solder. I've got two leads joined together by solder. You don't want that. If I get my head in the way, let me know. Okay, we've got the high side. Now for the low side. There we go. Okay, looks like we got everybody. Now that was the hard part. We'll put the control board on, and hopefully all is well. Unless the control board has a problem. But we've taken care of the shorted IGBT and the regenerative braking IGBT inside that power module. We have the control board installed. Now right here on the power board is RS&T, where we apply 220 volts AC 3-phase. That powers up the DC bus after it's rectified. Over here is the auxiliary input that powers up the control. Now it is also 220 volts AC single phase. Here's our I/O connections. On pin 1 we apply ground from an external 24 volt DC power supply. On pin 2 we apply that positive 24 volts DC. Here on pin 5 is torque enable. We could switch that to the plus 24 volts DC. And here's I enable, and we connect that to the plus 24 volts DC. Okay, let's power up the 24 volts DC, and then we'll apply 220 volts AC to the drive. Alright, FR, that's good, no alarms. Let me get closer to that display there so we can see it switch. Powering down. Okay, maybe we can see that display now. There we go. There's IN and FR. Now I'm going to jump. Kind of in the dark here. Don't get yourself lit up, people. I'm going to jump. Torque enable to plus 24. We have LO in the display. LO or L0, not sure which. Now, I'm going to jump that plus 24 volts to I enable. And it says EN in the display. I'm going to hook up the light bulb bank to U, V, and W. Let me power down, and we'll watch us paint through the light bulbs as I rotate that knitting machine's resolver. Now let's see if we were successful in our repair. There's 24 volts applied to the drive. There's 220 applied to the drive. We have FR in the display. There's torque enable. So far so good. Here's I enable. And I'm rotating the IRT motor's resolver by hand. Look at that. Let's go back the other way. Phew! You fixed another one. Good job, folks. That was a grizzly bear. Whew. Okay, I'll put the lid on it and we'll call it a day. Okay. Disabled the output to the motor. Turned off the 220 volts AC. Turned off the 24 volts DC. Let that DC bus die for a little bit, discharge. Then we'll put the lid on it. All right, folks. That was awesome. I hope you enjoyed that. But that was a grizzly bear. I hope you never have to do that. All right, all. Spend some time with your youngsters. Have a good life. We'll see you in the next one.